in an era where analytics has become a very approved and de facto platform by all the businesses. And in fact, we see that cognitive computing, deep learning, artificial intelligence, and machine learning are really at its full swing. So it's very important for us to realize and appreciate and acknowledge this fact as computer professionals. That's what I very deeply believe in, because I feel in the next 2 to 3 years, there will not be a single business that is untouched by even cognitive computing. While today I think analytics has become a reality, machine learning, cognitive computing are in its full swing, and the next 2 to 3 years, it's going to be just part and parcel of our life. So with that as the background, today what I'm going to do is take a webinar on something called Big Data and Analytics with Unified File and Object. The webinar is typically a little intermediary level in terms of skills that you would need to have to appreciate it. But at the same time, I think there's a lot of insights that you can gain even if you're coming from a different set of background. So what I'm going to focus today is what does it take for an ideal infrastructure in general and storage in particular for analytics-based deployments, right? Many times application developers are agnostic of what happens beneath in the infrastructure, whereas the actual architect deployment have to make sure that it's end-to-end, the entire deployment that they're doing for an analytic cluster, or even, for example, deep learning cluster is all, it's all optimum. In all of that, storage plays a very vital role, right? Because analytics is all about data, and data is all stored in the storage, whether it's going to be cloud storage or if it's going to be an on-prem storage, right? So we will actually take you through all of this and deep dive on what kind of storage architecture that you need to have when you plan for an analytic-based deployments. At the same time, if you're a developer working at an upper stack in analytics, you need to appreciate the fact as to how the architecture below should be or is, or what is the ideal design points for an architecture. So let's get started. So what is the agenda? I'm going to quickly take you all through a big picture, just so that we understand and appreciate what is unstructured data, what does it mean for, what kind of storage it is that hosts unstructured data, and what does it mean for analytics. Then I've divided this webinar into 2 sections. Part 1, where I will go through the need as well as the design points for something called unified file and object, right? And we'll go into details of it. And then part 2, I will go into how analytics with unified file and object can be achieved, right? And what kind of architecture that you need to, what kind of design points we have to meet, and what kind of platform you should really look for when you're actually planning analytic-based deployments, right? I've tried to keep the entire presentation platform agnostic, in the sense it is agnostic of technology in particular, though it is referenced on a lot of design points that we have thought about and implemented. So then let's get started. So big picture, unstructured data storage for analytics. So let's sit back and say, hey, what is growing today, right? When I say about analytics, first you would typically go to an analyst, try and understand what are the trends in the market. So I've captured on the left-hand side a trend which shows that by 2020, and this is no mean a surprise to anyone, right? Unstructured data will account for almost 80% of the overall storage, overall data that is created in this world. So then you would ask, hey Sandeep, what is unstructured data, right? What do you mean by unstructured data? So at a very simplest, simple terms, I've just, if you see the GIF in the center of the slide, it actually shows what are the different types of unstructured data, right? It is actually your emails, it's the blogs you do, it's the tweets you do, it's the presentations you make, it's the photos that you take, it's the videos that you make, right? So that everyone can appreciate it, right? More or less, it's also the logs that particular systems is generating. In the enterprise world, it's the transactions that are happening. And I've also given you the kind of unstructured data and the rate at which it happens. This snapshot shows you how many tweets happen every 60 seconds, how many Google searches, almost a million Google searches every 60 seconds, almost 11 million instant messages that are happening every 60 seconds. Now, this data point, the point I'm trying to drive is all unstructured data. Okay, so now we have appreciated what is growing in the markets, unstructured data. We have understood that what is unstructured data at a very high level. Then you would say, okay, Sandeep, what do I need to do analytics, right? So unstructured data plays a very important role in analytics. What is analytics? You're going to take a large chunk of data that you have, you're going to analyze that data and derive insights, right? At a very high level, this is what is analytics. So for you to able to derive insights from data, you need that data. And that data predominantly is the unstructured data, right? So the arrow up here shows what data is needed for analytics. It's the unstructured. Now that we have understood the trends and we have understood what is unstructured data and what data you need for analytics, you'd say, okay, but where do I run my analytics, right? Where does this all data go? So this all unstructured data typically goes in some central storage repository called either a file storage or an object storage. If you come from an storage background or an infrastructure background, you would typically immediately get what I'm talking about. But if you're coming from an application background, overall deployment background, I think what file and object storage are is nothing but a set of sophisticated systems that sit in data centers, which take, it's kind of a large hard disk at a very naive level, right? But it's important because this actually takes care of all the data that is sent. So for example, if you're uploading a particular image in Facebook, where does it go, right? When you say, so it goes into a storage. Now that particular storage is typically either a file storage or an object storage, right? What is a file storage? As we all know, a file storage typically, many people tend to use the word network attached storage, but is a storage that hosts file. A simple example could be your NTFS file system on your Windows laptop or an XFS file system on your Linux box, right? Which is kind of a file system which is hosting storage on a hard disk. But in an enterprise world, this is at a very large scale. Similarly, there has been an emergence of object storage, right? And object storage has been specifically designed for catering to such workloads and such type of data. So what I'm going to do next is I'm going to assume that we all are aware of file storage, at least the basic norms of file storage. And let's deep dive into object storage and why there's a lot of buzz in this market about object storage. So part one, need as well as design points for unified file and object, right? This is where I'm going to go to, but before I build that particular story, you should first appreciate what is object storage. So introduction to object storage. What object storage? An object storage typically is a very highly available, distributed, and eventual consistent storage, right? It's very similar to file storage, but the characteristics are very different, right? It generally is a software, it's most of the time completely software based and that runs on commodity hardware, right? It has certain characteristics like it makes use of replication, and in sophisticated object store, it actually makes use of erasure coding, like implementation of Reed-Solomon algorithms, etc., to make sure that the data is durable, right? It is highly available on the object storage. Now, just so that you get a quick context about object storage, because we're going to deep dive into it. If you have heard of OpenStack Swift, or if you have heard of Amazon S3, or an IBM Cloud Object Store, they all are the popular object storage out there, right? So it's kind of an storage that has been specifically designed to kind of cater to this big data and cater to these newer unstructured data, and in such a way that it can actually cater to the cloud requirements, right? Now, what are they? Let's go a little detail in it. So an object storage enables the next generation of data management, right? I would not be surprised, almost every other enterprise 3 years from now will have an object storage in their particular data centers all across India. right? There are already customers, big banks who already have object storage and have started deploying object storage. So what are the semantics? What are the key characteristics of object storage? So one thing is object storage was designed to have very simple APIs. It has to work over HTTP protocol, right? And it has to have a very simple semantics of putting the data and getting the data. And hence it is based on simple REST APIs. The whole operation is simple REST APIs: put, get, delete, post, head, etc. Right? So very simple semantics. Two, generally these APIs should have some accent. The most popular accent is the S3, the Amazon S3, and the other one is the OpenStack Swift. That is the API language that applications can use to talk with an object store. So if you have a phone app you want to directly put into an object store, you write an put API following the semantics of the object store, and the photo will go and store in the object store. That's what happens in a lot of these big websites. When you upload photos, what's happening is putting internally that particular website is actually throwing that photo onto an object store using the REST APIs, right? And it is a little different from file, but file has different semantics. So typically file is used when you need very high, for analytics, typically you need a file system, right? But for storage, you need an object storage. Why? Because it's scalable, it's supposed to be cost efficient, right? It's supposed to have a ubiquitous access because it is based on HTTP. By inherent, it has to be multi-tenancy because the entire object store was designed for the cloud where multi-tenancy is a requirement. It has to have a metadata support. It's very important, where every object you can actually tag things. For example, if you upload a photo, you can actually have your face recognized. That is actually a tagging, and it is stored inside the object, in the object metadata, right? And it has to be scalable and highly available. So these are the key characteristics of object store. So now you would say, okay, Sandeep, for analytics, you have told me so far we need big data is important, unstructured data is important. In a typical data center, if you go, you would say, I have my traditional applications or traditional databases running, which is running on my block storage. Then you would say, I have file storages, which is actually backing up all my websites, etc., and trying to keep, and I'm running some analytics on my file storage. And now you're telling me the world is moving towards object storage. So I'm going to even have an object storage. So what is happening is I have silos inside my customer data center. I have part of it for file, a farm of file storage. Then you're saying now there'll be farm of object storage. Management becomes a nightmare. Moreover, data becomes siloed. Some important data is on file storage, some important data would be on object storage. This becomes a mess, right? And mess not only for the management of it, mess even to actually do the correct analytics, because you know the data is spread across different islands, and you really need to consolidate that data and have it in a single place so that you could run the analytics on the data there and then and get the insights, right? So this is the problem that is surfacing with a lot of data centers. The problem is storage islands. So this has to be fixed. And I will take you through the approach, the architecture, the design thinking of catering to this. So unified file and object access. So when we thought, you know what, there is this silos of data happening, customers, admins are trying to manage, application is saying, sometimes you tell me, write to this particular path, now you're telling me start doing put, get to this, it's all messy. Can we have something like a unified file and object access? Can we move to a state of nirvana where the right design point has been done, despite of the industry moving here and there, and we have a central, well thought of storage subsystems that can especially design for analytics. So that was the thinking. So then now you're saying, okay, Sandeep, then what is this unified file and object access, right? Can you go to a little detail of it, right? So what happens in the file world? You typically have, how do you access file storage, right? Many times you're agnostic of it, especially if you're an application developer, if you're a systems developer, you know there's a file system out there and you're going to keep things. But even consider, for example, there are potentially three main interface for accessing files on a file system. The first one, which is the most important one and the most common one, is POSIX. That's when, for example, in DOS, if you go to C drive, that's a POSIX access, right? Linux, when you go to XFS file system, you go to CD to a particular /root or /home Sandeep directory. That's a POSIX access. You're trying to access your file data through POSIX. Similarly, there is NFS and SMB access. What happens is if all the storage is centrally managed, you have a lot of clients, and this happens in enterprise world, who want to access that data which is centrally stored. So in the Unix world, we will use NFS to access the data which is central, which is a network file system. And in the Windows world, there's something called SMB, which is an IBM, it's a Microsoft proprietary protocol, where you have to support so that Windows client can access the data which is hosted centrally. Right? So these are the typical most common interfaces used for file, SMB, NFS, POSIX, and all the applications work using these. Now I told you an object, it was all designed to be on HTTP, and all the access is using REST, right? So now we have understood, okay, file, you have these three protocols, object, we have REST, and they all are different because object semantics is different, file semantics is different. People have developed different appliances or different software-defined storage for it. Now the key is, let's access object using file interfaces. What should happen is, you should say, as an application developer, I'm already used to using the file interfaces. Can I start gradually and automatically moving to file or into object? There are going to be a lot of applications. There are going to be a lot of developers who are born in the cloud. That means they have been designing applications right from their birth in the cloud, right? Or the applications have been designed and brought in the cloud. When that happens, that application is predominantly directly integrated with object stores using REST. Now you would say, you know what, there is a need that sometimes I need file access for doing super fast analytics. Can I have that data into file access? So this is driving the need of having a common data platform, a single namespace for the data, and being accessed by the file interfaces and being accessed by the object interfaces, right? And just imagine the role of an administrator. He'd say, okay, it's world so good if I can just manage both of the systems with a single interface, right? So that's the design point, and that is what unified file and object is. What this particular diagram on the right-hand side is showing is, you have object, like your photo, right? You're going to click a photo and you're going to upload it. So data ingest as object. So it goes into something called, it's a storage. I will peel the onion for you about what is clustered file system and later. And then you should be able to access the same object that is put through other file interfaces or through other interfaces that are available for the applications, right? For NFS, SMB, and POSIX. Similarly, when NFS, SMB, POSIX, if there is some file, a log file that has come, right, and you want to put it, I mean, a log file, generally you will place it, it's a file, you have placed it on the file system or on a file storage. You would say, I want to have an access of it to my application, which is in the cloud, or application on my mobile phone through HTTP. So that should be available through the object interfaces, right? So I'm trying to trivialize this. There's a lot more than this, because about the semantics, about how do you make sure that the data consistency is maintained, how do we make sure that the unified ID mapping is maintained. But for a very large audience, I just want to generalize it and make it at a high level. So that is what it is, right? Multi-protocol access for file and object in the same namespace with a common user ID mapping, right? This goes into details about what is user ID mapping. Every user is known as an ID map system. If we all are computer engineers, we know that user Sandeep, the system is not going to understand who is Sandeep, but Sandeep is represented as an UID, as a unique identifier by the system. So it's important that when the underlying system comes, or Sandeep comes, he needs to understand who is Sandeep. He's number 10. So this number 10 should be understood even by the object interface. There are details onto all of that we don't have to get bogged down currently, but it's a design approach. So optimize various use cases and solution architecture. What happens is, when you approach a system in such a fashion, it enables you to have an optimized solution architecture. You don't have to worry about, should I get another object store, should I get a file storage? It's all unified. Now what you are seeing here is a clustered file system. Quickly to get in nomenclature, a clustered file system is nothing but a file system. people on Windows, it's NTFS. You go C drive, that's NTFS file system. You go to Windows, it's Linux, it's XFS. Similarly, a clustered file system in enterprises is a state-of-the-art HPC file system, a file system that sits across systems, right? And it forms a cluster across all the systems. That's a clustered file system. And in it shows Swift on file. So Swift is the object store from OpenStack that you can actually make it sit on a clustered file system. An example of clustered file system, the best example I'll give you is IBM GPFS. That's the General Parallel File System, also known as IBM Spectrum Scale. You just Google it, you'll come to know what is IBM Spectrum Scale or GPFS. There are other open source file systems like IBM Luster, as a Luster, etc. Out there also, so that you just understand what is a cluster file system. Right? And then Swift is the object store. You can actually place object store on a cluster file system, and that is what was our design point to actually make this happen. Now let's go into the next level of details. Right? Now you say, Sandeep, okay, what we have done as design points is we are trying to get an cluster file system so that it can actually span across multiple systems. And we actually took an object store from open source, let's say a Swift object store. We place it on a cluster file system. And we have to design so that a file is seen as object, an object is seen as file. So it's like magic. And if you're really interested to know the design, we actually open sourced it. It's there on YouTube. If you just Google for me in Austin Summit, we had actually talked about the entire design and opened it to the world, which shows how you can actually make it happen. So once we make it happen, we'll say, okay, Sunny, what have we achieved by doing this? Right? So this is a quick use case, which is of a media house. What it is showing is that in media house, there are generally various subsidiaries associated with a media house, right? So you see a subsidiary one, he takes the actual live footage and he transfers it to a central storage in his private cloud, right, through the REST interfaces. As soon as it comes, the footage has actually come as an object. So you can then actually apply analytics to it and actually auto tag all of that, which I'll take you through later. And then what you do is, since that particular video file or image file is, that has come in from the subsidiary one, you need to do some kind of video processing for it, right, before it is published. So video processing can't work on object store. Object store are REST APIs like a cloud storage. So you need a file storage. So what happens is, since we have unified file and object, you actually get that particular data, and now that data is that, since we are running unified file and object, is available on the file interfaces, and you can actually run a farm of VMs doing the video processing as shown in the figure, right? And you do the video processing, and then you push that particular final image. And now when you push that particular final image, you would say, you know what, I want to publish it to YouTube, right? So it has to go through REST. So you can actually push it. You can just use your YouTube APIs, plug in into your object store, and the final video is available for processing. One thing, if you appreciate, if you actually peel the onion, you'll come to know that we have actually not done any data transfer. The data came in from the photographer. It was there on the single storage. It went for processing, it is still there. It was processed, it is still there. After processing, it is published to YouTube, it is still there, right? No movement of that particular data, which is a big deal in terms of network and in terms of storage consumption, right? So let's move further. Now that we have appreciated unified file and object, right? You would say, okay, Sandeep, let's get into now analytics for unified file and object, right? So we understood, you remember the chart one when we talked about big data, we talked about all the analytics, you think, and I was going to tell you about the solution design points. So one of the solution design points for you to take away is your deployment should have a unified file and object storage, preferably. Part two, analytics with unified file and storage. So what is big data analytics and its challenges, right? So a field of data science. When you look at data science, I was actually looking at how can I give you one slide which talks about data science. And this is a slide, after thinking a lot, searching a lot, kind of puts it up well. It is about taking the data, both structured and unstructured, getting the context and building the context, analyzing the data, embedding it with metadata, and then trying to do analytics to derive actionable insights for the business is kind of what is the field of data science, right? And in this, if you really see, and I wanted to emphasize, is the big data part. If you look at the big data part, you see it's all about unstructured data, social media, survey research, sense making, sensors, right? All that chunk of data is unstructured data, right? And that is where, when it's unstructured data, the file and object store becomes very important, right? And because end of the day, you're going to run all your applications on that particular storage, right? So now we have appreciated the fact that field of data science, where analytics is a part of data science, it's all about data. And when it's all about data, unstructured data is playing an important role, many times referred as the big data. So then how do we define big data? Right? In a very generic sense, a big data is a term for data sets that are so large or complex that traditional data processing applications can just not handle that kind of data, right? They're so huge, right? And there are various challenges. The challenges actually start from actually capturing that big data, then curation of that particular big data, storage of that particular big data. You have to search that big data. Then you have to share that big data with your collaborators. There's a lot of transfer involved when you do this. You have to actually analyze the data, and finally, you have to visualize the data so that you can show what this is your business insight, right? So challenges in different phases. Then there are some key characteristics of big data that you need to appreciate and understand. I've listed down 6. The first 3 are the most critical one, while the next 2 are also important one. But the first 3 are the fundamental one in my humble opinion. One is the volume, the quantity of generated and stored data, right? Big data is about all huge volumes. Just so that you appreciate, today almost 2.5 quintillion bytes of data is generated every day, right? So I have to actually think of how do I pronounce even that. So that means what data is actually generated in the world today. That actually talks about volume. And most of the data is unstructured data, which is big data, right? Then you talk about the variety, the type and nature of the data, right? If you've really seen, the variety of data has been growing, right? With the IoT, sensors, RFID devices are all spitting out new data. People are clicking videos, videos through their phones, photos. That's all different forms of data, right? There is sentiment analysis. There are blogs. There are tweets. There are different types of data. So the variety of data has started to increase exponentially. And the third is the velocity of data. The speed at which this all characteristics of data is coming is substantially higher. Just so that you can appreciate, Walmart actually does over 1 million transactions per hour, right? Almost, I would have almost said per day, it's a per hour, 1 million, more than 1 million transactions. And all the transaction and the backend is generating unstructured data and relating to structured data. So there's so much of data, you have to now process all of the data and actually get the real insight. So now we have appreciated what is big data, where it resides, and what are the characteristics. Now this is an important one as to what are the challenges with the early big data storage models. So we know all this data is going to come and reside in storage. That's where you're going to write your application. It's going to take the data. What are the challenges that the industry faces, right? So now challenge number 1, if you really see, is there is more data source than ever before, right? In the early days, there was only one thing. There's an OLTP workload. There's a website talking with that OLTP and it comes. That was one. But today, I think more data sources than ever before, as you see on your left-hand side, with IoT, with different devices. And not just data your own, but public or rented data as well. Like people are talking about your products and stuff like that. So there's a lot of data that you have to ingest. Then what happens is once the data comes to you, you have to move that particular data. Very important for analytics. You get that data is in silo. You have to move that data into one central location so that then you can run your applications on top of it. If it's a Hadoop application, you run your applications. You have to move your data, right? All of of a sudden, with analytics, as we stated before, has become a de facto standard in most of the businesses. Key business processes are now dependent on analytics. So you need to make sure that, at least from a storage model, they are savvy for running analytic workloads. Now, it's just not one type of analytics. Now, when you talk about analytics, you know what, there's Hadoop out there, there's Spark, there are going to be SaaS, SAP HANA based analytic workloads, etc. So that's another challenge, right? And the final one is, you just can't throw away this data, right? You have to maintain this data for regulatory purposes for most of the businesses in the enterprise business. And then all of this, you have to keep repeating this over and over again. So when you sit back and see as an architect saying, okay, these are the challenges with the big data storage models. And then you say, okay, now let me think about the design points that I should have with these challenges. So now we will go next to understand what are the design points, approach and solution to solving this, so that end of the day, I'm going to run a Hadoop application. It is going to run with the state of the art optimization. So what are the solution design points that we came? Number one, after all these set of slides, what we come to, okay, now I want to design a particular nice, perfect, optimum storage subsystem for analytics. What do we need? One, we need a single namespace to house all your data, both file and object. You've gone through the journey of what is file, what is object, right? Two, unified data access for file and object. We went through earlier, file in, object out, object in, file out. So this is what I need. Three, encryption for protection of data has become, according to me, encryption is no more a regulatory requirement. It has even become a personal requirement, right? I don't want even my personal data to be hacked. It's so important. So encryption becomes utmost important, right? Number four, end of the day, we live in a sensitive world in terms of cost. We all are cost sensitive. We need a good solution at an optimum price, right? So we should make sure that the economics are optimum and we have value for the data that a customer can justify, right? That means what I'm showing is you have different types of disk today. If you really go and purchase a particular disk, you see, why is this particular disk so costly than the other disks? It depends on the speed of the disk, the durability of the disk. If you go and store in the cloud has certain characteristics. So there are a bunch of options available for the actual physical hardware for storage, and you should make sure you are able to support all of them. Fifth, geographically dispersed. Today, actually, the world has got smaller because we can actually spread our data, spread our business geographically because of internet. And hence, it's important that the solution should be geographically dispersed, managed, so that the data and including disaster recovery is taken care of. And finally, the most important point is bring analytics to data. We don't have to take data to the analytic engine. Bring the entire analytic to the data and make it faster. So now this is a little, it's a little cluttered is what you would feel, but take a pause and I will go step by step before I go into these circles. Right? And this is a chart that actually I can talk for ages, but in the interest of time, what you see below is a clustered file system. As I explained below, what is a clustered file system? It's a file system which enterprises use, which sits across all these systems, etc. Best example is IBM Spectrum Scale. That clustered file system should have automated data placement. It should automatically move data from one tier to another tier based on the value of data and the age of the data, right? Then you should have a global namespace. Very important. Now you would say, Sandeep, what is a global namespace? If you're into storage, you would already understand. If you're an application developer, a global namespace means you should have a view of the data from the same path, irrespective of where you are or where you're accessing from. That's called a global namespace, right? So that is global namespace. Then you have file access, you have analytic access, you have block access, OpenStack, since it has been this, you have means from OpenStack access, you have object access. At the top, what I have shown is different kind of applications that actually run on these systems, right? If you're an application developer, you'll be all familiar with, yes, I know MongoDB, I know Cassandra, I know Kafka, I know Hadoop, I know SAP HANA. I am a person who actually works with SaaS applications. All that ecosystem sits over what I've shown below, right? And it's important, if you understand both the worlds, you really can appreciate the entire system as a whole. You have client workstations. And then on the left-hand side, I show you that you have actually spread across different geographic sites. And very important, now that the world is moving towards the cloud and already shifted towards cloud, I would want to rephrase that the world is actually hybrid cloud, not really cloud, it's hybrid. That's actually the reality, right? So it's important that your central deployment should also have a facility to have your data move between your on-site cloud, private cloud to your offshore private. So that is one which I show on the left-hand side. And encryption, of course. Predominantly, your secure data at rest should be ensured. So anything that you store at data. So this is what this particular slide is. And what I really show when I circle is the particular design points that we met when we understood what were the design problems, right? So if you go to the previous slide, when I showed you all the design points in circles, on this slide, I'm actually showing you which are the circles which are addressing those design points. For example, meeting design point 1, where we wanted to have a single namespace. Everyone should be singular. I don't want one system somewhere else, other system somewhere else, and I have to change C drive, D drive, machine mount, everything single namespace. Design point 2, right? Very important, unified file and access. I should be able to move, if an application is born in the cloud, it is born for object store. If an application is typical, it's a legacy application, it is going to work on file, and both should be able to access the same data, right? Then that's design point 2. Design point 3, as we said, encryption has to support encryption both for secure data at rest and secure data in motion. Design point 4, economics. We have to make sure we support different kind of storages that's available in the market, so that my data for analytics can actually state into different cost points of storage. Design point 5, my data center is going to spread across geographies, right? So you should be able to make sure that my data, if it's in Delhi versus Bombay, I'm able to support all these sites with the same design points, right? And design point 6, which is the most important design point for today's session, is bring the analytics to the data, right? And that is where you see what we did is we took a cluster file system. We had a file interface for POSIX. We developed the NFS SMB so that it caters to all the file interfaces, right? And I'm not mentioning product names explicitly because I wanted to make it agnostic of particular technology. Then we took the analytics, the HDFS Spark, and we developed transparency connectors. So we go and understand how does, it's all open source out there. You can actually understand how to make an HDFS file system or a connector so that Hadoop can run on top of it. We did it, same thing for the blog, for the iSCSI access, OpenStack with the Cinder and Manila, and finally the important object store with the Swift access and the S3 protocol access. Right? So this kind of gives you a picture saying, okay, this is how we have developed and addressed all the design points to the data ocean approach to meet the ultimate goal of bringing the analytic to data. Now a little bit of analytics. Now you would say, okay, Sandeep, you talked about the data, but what about the analytics, right? So in analytics, I'm taking a case point of Hadoop. I'm sure a lot of the audience today would already know what is Hadoop, but just to set the context, I think Hadoop has become a key platform today for big data analytics, right? I would say Hortonworks is one of the premium distribution for Hadoop out there available. But a lot of people are deploying Hadoop to actually gain business insights and run Hadoop-based applications. So what is it? It's simple, an open source software framework and most popular VDNA platform out there today, designed for distributed storage and processing very large data sets, the big data that we talked about. Quickly, what are core components of Hadoop? It's basically, there is something called map reduce, which actually allocates tasks. There is a base, something called Hadoop distributed file system, the HDFS file system. If you're aware of Hadoop, how it works with an HDFS file system, you have a map reduce, you have to transfer the data and does the analytics there. And Hadoop common libraries and components. So there are many common libraries and components like Pig, Hive, etc., which actually work over Hadoop. And obviously there is Ambari, which actually helps you deploy the entire analytics. So this gives you a context of what is Hadoop at a high level. So when we looked at Hadoop, what were the shortcomings of Hadoop, right? Rather, what were the shortcomings of HDFS when we had to make sure that this infrastructure is being built uh, for analytics platform? One is HDFS is a share nothing architecture, right? While it is supposed to be strength, actually it ends up being its weaknesses because uh, eventually it's inefficient for high throughput jobs if your data is really big. Two, it's generally a little costly because you have to do three-way replication. There is no RAID, no erasure coding, so data is constantly moving. Works only with Hadoop, weak support for file and object. Object does not work out there. And clients have to copy data from the enterprise storage. Very important. Here is all your data. You have to make a special cluster file system, copy your storage, and actually run it. Right? For example, this is a good slide which shows the problem. What happens today when you look at the Hadoop-based clusters? Right? What a data scientist wastes days just copying data to HDFS. You have to take a lot of data, which is raw data. You write it to an ext4 file system, right? Which is, I'm taking Linux in this case, or XFS file system. You've ingested all the data, all your unstructured data from everywhere. You've come on your Linux system. Now you want to say, I want to run Hadoop-based application. What you have to do is you have to actually deploy an HDFS file system, right? And then move this data. So if you want to run analytics over, let's say, 50 terabytes of data, you actually have to move 50 terabytes of data to an HDFS file system. Movement is costly. It requires a network, right? And second, you need extra storage. Right, 50 terabytes of extra storage needs to be provisioned to run Hadoop analytics. So then you run that analytics and Hadoop jobs, you derive your insights. Once your insights are done, then you have to copy back the insight to your ext4 file system, which is a persistent file system for you, and then your traditional application feeds. So this is like 1, 2, 3, 4 hops. The design solution should be in place. And that is what I talked about earlier, where you would have raw data. You directly ingest it into a cluster file system like Spectrum Scale, right? And you can ingest it using whatever you like, NFS, SMB, Object, POSIX. There can't be applications other than these 4 interfaces out there who need a different kind of interface. So all are covered. You put your raw data in. Now you want to run your analytics, right? Now this Spectrum Scale is a cluster file system mostly used in supercomputers and HPC kind of environment. That means you have actually the power behind that file system. So you run your actual analytics on top of it. You don't need movement. You don't need extra provisioning of data. So you run your Hadoop-based analytics. And once you're done, you get your results, and the results is out there itself. Right? You can directly publish it to YouTube or directly move it to application which need it with whatever interfaces they need. Right? So this is actually what I wanted to convey of having a design point with in-place analytics, no copies required, using a cluster file system. Right? And this was kind of how we approached the entire, I'm just trying to show you how we approached towards where we are with Spectrum Scale, but this is a generic design point and architecture thinking for analytics and choosing the right infrastructure and storage specific. Quickly, another one, what this shows is in-place analytics for unified file and storage. On the left-hand side, what you see is typically what you do in Amazon. When in Amazon, all the data is on Amazon S3. What you have to do is whenever you want to actually run some analytics, you have to provision an EMR, use an EMR, provision a Hadoop cluster, move your data from Amazon S3 to that HDFS-based cluster, which is an EMR service, run your analytics, get your data, move it back. I don't have to tell you, all of us are engineers. We come to know, what, there's not optimization. You have to move the data, you have to provision separate clusters. On the right-hand side, what we show is with this design, everything comes in place. Your object is there. You get the power of unified file and object and do in-place analytics. So this is what this particular slide is showing. Now, quickly on my last 2 slides, you're saying, okay, Sandeep, you touched upon analytics. I also said that the world is moving towards cognitive and cognitive computing, deep learning, artificial machine learning. What do we do with the storages and cognitive? So cognitive services, what are cognitive services? I think cognitive services are based on technology that it's kind of encompassing machine learning, deep learning, right? And flavors of natural language processing, speech, vision, um, image processing, and more, right? The best example that you will get is IBM Watson Developer Cloud. If you're not used to Watson, just Google for IBM Watson. You will actually go. There are free examples out there, and you'll be wowed if you're not into deep learning to see, hey, you can do all of this, and all of these are available as APIs for me as application developer. So I get the power of an Watson directly embedded into what applications I'm doing. So IBM Developer Cloud enables cognitive computing features in your applications by using an IBM Watson language, simple REST APIs that you can do. As an example, if you see a person doing skiing, right? Now you want to tag this particular photo. All you have to do is feed it to a cognitive system like IBM Watson, and when you feed it, it will actually return you the result that I'm showing below, where it says, I think this image is about ski, and this is my score. It is about sport. This is my score. This is about skiing. This is my, and this is about snow. And then based on this, you can tag all of this. So it analyzed the image and told you what the content is. Similarly, another service is speech to text and text to. For example, if you go to a call center, and if you're an owner of a call center, you want to make sure that people are attending the call and are polite to the customers. So how would you do that? You can't monitor each and every call. So what you do is you get the entire call, which is in voice, you convert it into text using Watson services or cognitive services. Then once you convert it into text, you get the text and feed it into another cognitive services, which does tone analysis, which understands what was the tone used by the particular person when he was converted. So, and then you can tag that particular video or particular call as, okay, a good tone, a bad tone, a harsh tone. And then you as the owner of a data center can say, okay, let me review all the harsh tone used by my call center people. I'm just giving you an example. So all this is what is cognitive services. Now, how do I tie it to the storage that we did? Right? Cognitive services helps to derive meaning of it. Right? So how do we tag it? So what we did is, okay, we are an unstructured data. We have designed a storage subsystem which actually is able to cater all the analytic needs. What about cognitive, right? And that is where what we did is we integrate cognitive services with the object store so that it auto tags that particular those particular objects, right? And here is a quick example. So how it works, right? So let us say you are a person, you are on a vacation, you go to Paris, you take a photo. When you click a photo from your phone, and then you put it on an object store. In this case, it is IBM Spectrum Scale Object Store. Once you put it, you'd say, okay, the photo has gone. It is there in IBM Object Store. It is made sure it is all durable, reliable. And then internally, we can feed that particular data to IBM Watson, which is a computing cognitive service, right? And it would then analyze that particular data, and you don't even know, right? It will say, okay, this data is of Eiffel Tower. This is an actual example we did, right? It's a tower and it's a tool. So it's given you what exactly this is, right? And then we take those tags and we auto tag it to that particular image. And you didn't do anything, but on your phone, you can see, hey, all my images have started getting tagged. What is happening? But at the background, the storage that we talked about is speaking with cognitive services and doing this tagging. So this was more about how the world is moving towards cognitive services, and even storage is embracing it. There's a lot more we could talk about cognitive some other day, some other time, in terms of how integration of deep learning, cognitive services, what it means for storage subsystems, compute subsystems, etc. In some other webinar. So with this, I think the design points that have been incorporated in IBM Spectrum Scale, all that I said is incorporated in a product called IBM Spectrum Scale, which is the #1 software-defined storage by IDC, and IBM Elastic Storage Server. If you want to know about it, you can just Google about it. And now IBM Spectrum Scale, we have also partnered with Hortonworks so that we present the best, present a state-of-art big data and analytics solution, because Hortonworks being the premium Hadoop-based platform, and Spectrum Scale has been designed for, because I took you through the entire design approach of how one should approach it, designed for analytics, both coming together become state-of-the-art analytics solution. With this, I would want to thank you all for being a patient audience, and will open up for any questions. There is a list of questions and I have about 7 minutes. So let me see. Is the data ocean which referred here is somewhat similar to data lake concept? Good question. And yes, Mohit, it is similar to the data lake concept, just that if you go to a real enterprise, the data lake is a little smaller than a data ocean, where actually we believe that it's a wider scope than a data lake scope, but you are actually right. Next question was, can spectrum scale be compared to smart data access for SAP HANA, where data is analyzed on Hadoop and results are fetched from Hadoop cluster using SDA interfaces to SAP HANA for reporting? Again, a good question. Thanks, Anish, for asking. Actually, spectrum scale can't be compared with smart data access for SAP HANA, because I think a lot of not directly access, while your second part of the question is right, but SAP HANA actually sits on top of spectrum scale. If you just Google for spectrum scale and SAP HANA, just Google for it and you come to know that how spectrum scale and SAP HANA work together and still provide what you've actually written. So I hope that answers that question. Next is, why is Hadoop not preferred for analytics? So Arvind asked this question. Arvind, I would slightly differ. I think Hadoop today is the predominant platform for analytics. Well, there are other analytics also. In the SAP world, it's SAP HANA. In Spark is actually taking over for in-memory analytics, but Hadoop remains one of the predominant data platform for analytics today in the enterprises. Next is, how can we as IBM employees can be a part of object store development? You can get in touch with me, and if you're an IBM internal, you can just get in touch with me and we can talk about it. Mohit asked, is a data ocean which you referred, I've covered that. What is the security measure that can be taken for big data? It's a good question. It's a longer question as to what are the security measures that you can take. But if I have to answer it in a minute, big data security is no different than any other data security if that particular data falls into classification that requires security, right? So you can classify data in which there are only 4 concepts that you have to take care of. PAIN, pain, privacy, integrity, authentication, authorization, and non-repudiation. If you can fit the pain characteristics of security to big data, it will address that. So the next one is, there's a lot of questions pouring in, so I'm glad. Please email us the PPT. Sure, in fact, I hope Spring people should make this available for you. Sorry, Spring Minds. Can these objects stores be ingested to HDFS? Very good question, Anish. Yes, that's because what we have done in spectrum scale, you ingest data through object. The HDFS interface is available there and then. So that means you put here immediately HDFS data is available for HDFS. So your answer is yes. Okay, Anish Gupta, can both of these reside on the same IO storage? What is the storage extension which is used for Swift and S3 storage? So these are the extensions that come with OpenStack Swift. Just trying to see if there are any unanswered questions. How is it different from block and file storage? I try to understand how is it different from block and file storage, because object storage, I refer to my first 2 slides, which talk about a different concept, which is more to do with cloud, REST API, scalability, etc. The basic characteristics are making sure that the data is never lost, remains the same for all storages. But object storage was designed more to cater to the cloud requirement. So there was a question saying that you said unstructured data, we need unstructured data for analytics. Can we do it for structured data? Surely. Actually, the end analytics incorporates its analytics on data. Data can be structured or unstructured. Both forms are available, right? And you can leverage both forms to do analytics of data. Hadoop is generally done on unstructured data. Similarly, there are SaaS-based applications which do analytics of structured data and many more. So there's another good question saying IBM from Tejas Mahajan, who says, does IBM Watson reside on spectrum scale? Right? IBM Watson is a closed system, so I would not be able to comment whether it resides on spectrum scale or not, but there are very strong synergies with the storage that we use in Watson and with what I've been talking about. Jonathan asks, how do we work towards a random forest? I didn't quite get the question. Maybe it requires a little more discussion on what does it mean, what did he mean by random forest in the context that we discussed. And I'll get in touch with Jonathan on that. This was a really interesting topic. Can you give us an interface or a virtual platform to learn in depth and have a thorough understanding? Sure, Abdul, if you could just follow me on LinkedIn, I will actually post all that I have talked about, and I'm even happy to point to a virtual platform that you will be able to get a virtual machine and do all that I talked about on that virtual machine. It's 90 days free trial, which I will be able to pass it to you. Just connect me on LinkedIn and I should be able to do that. Pulkit says, I want to move into Hadoop file. So can you suggest me how can I move to Hadoop file? Right. So Pulkit, it really depends what you're talking about. If you are an application developer moving to Hadoop file, it's open source. You can actually play with it. You can use the VM that I can pass it to you for your. But if you're actually an enterprise and if you're talking this through an enterprise mindset, then you potentially would want to look for characteristics of the file storage that I talked about for catering to your requirement. Vishal Kesti asks, how can we use this technology to address large log files generated after regression cycles? How can we use this technology? To address large log files generated after regression cycles? It's a good question. There's a lot of log analysis that we do, right? Where do logs come from? Logs come from appliances, devices, sensors. They come from systems. We can actually get all these logs into a central repository. Many of the IoT devices splits it through object store. Some could directly come through file storage, some come through application. You can consolidate it. Once you have the logs, you actually can run your log analysis application on top of it using all the mechanisms that we explained earlier. And this is the last, to appreciate everyone's time, it's the last question I'm taking. How the objects are stored in actual hardware. Still, these objects are mapped to XYZ ABC format. Very good question. I think Prabhat has asked a question which goes to the next levels of nitty-gritty of how is object mapping done. So in unified file and object, we make sure an object directly maps to a file, because only when that happens, when we do that magic, can you see a data as object as well as file, so that it is seen as a single entity. So at a very high level, an object is a file in a unified file and object storage. There's a little bit details to it. You can actually Google for my name on YouTube. There's a presentation we gave at OpenStack Summit in Austin last year, which talks about all these details. With this, it's almost 4 o'clock. I will still answer the questions, maybe by text, but with this, I would like to end today's session. Before I end, I genuinely want to thank all the audience for turning up today, because this shows your enthusiasm towards such a topic. And as I said, we are in the era of analytics, deep learning, cognitive computing, and in which infrastructure planning your deployment plays a predominant role. And I hope I was able to convey some of the architectural thinking and decision making when you actually go on to set up an infrastructure for analytics. Thank you so much.